Alright, this is the homework tutorial for 7-5, Attributes of Logarithmic Functions. Okay, first section, write each equation in logarithmic form. Remember, we're going to use the y, or x equals b to the y is the inverse of the exponential equation, and to write that in logarithmic form, we write it log b of x equals y. Okay, so let's do the couple problems. 32 is equal to 2 to the 5th power. To write that in logarithmic form, we write log. Our base is 2, so we put that as a subscript. Base 2 of 32 is equal to the 5th power. Okay. All right, number 3, 625 is equal to 5 to the 4th power. So, again, log. Our base is 5, so that is in subscript of 625 is equal to the 4th power. Okay? Alrighty. Write each equation in exponential form. We're going to go from the log base b of x equals y to the x equals b to the y. Okay, or the base to the y. So let's look. Our x is here. So 9 is in our x position. So 9 is equal to base of 3 to the 2nd power. Okay. Number 6, log base 8 of 512 is equal to 3. So our x again is 512 is equal to base of 8 to the 3rd power. Okay. All right. Number 8 and 9 says to evaluate each logarithm. Okay, so we've got the logarithmic form. Okay, we turn it back into exponential form, and then we're going to get x and b into like bases and then solve for x in the exponents. Okay? Excuse me. Alright, so first of all, let's turn this back into 256 is equal to 8 to the x power. Okay? Now, 256 is 2 to the 8th power. 8 is 2 to the 3rd power, and we raise that to the x power. Okay, so we've got 2 to the 8th power. Now remember, we said when we take a power and raise it to another power, we multiply the powers together. So we have 2 to the 3x power. And then we're going to take and we're going to look only at the exponents. So we have 8 equals 3x. We want to solve for x, so we're going to divide by 3. So 8/3 is equal to x. Okay? Now, log 125 of 1/25. So we have our x is 1/25 is equal to our base 125 to the x power. Okay? Now, I did it again. 1/25, we have a base of 5. Okay? 1/25 is an inverse, we know, because it's 1 over something. So, negative, and 25 is 5 squared. So, the 1/25 is 5 to the negative 2. Okay? And then 125 is 5 to the 3rd power raised to the x power. gives us 5 to the negative 2 equals 5 to the 3x. Again, look at just our exponents. We have negative 2 equals 3x. Divide each side by 3. And we have negative 2/3 is equal to x. Okay, next section says find the minimum and maximum of f of x equals log base 2 of x on the given intervals. There's kind of a sketch of what that graph looks like, and we've got the first interval is 1/2 8. So remember, we are looking somewhere around here to somewhere out here. Okay, and that graph goes in one direction, right? So it doesn't change. So we can look on the ends and find what our graphs are, right? I mean, our minimum and maximums. So I graph this out, and I am looking at my intervals, or no, well, I graph it out, and I'm going to look at my table is what I mean. And I'm going to set my table set to where I start at 0, and the delta is going to be 0.5 because I'm starting at 1/2, right? So I need to see 1/2. And at 1/2, my minimum is -1. And then I'm going to go scroll up to where I find 8. 6.5, 7.5. There's 8. 8 is 3. So I have a maximum at 8. My maximum is 3. Okay. Then I'm going to do the same thing on number 12. Number 12 has an interval of 4 to 32. Okay, so my minimum at 4 is 2. And my maximum at 32 is 5. Alrighty, so just look and find your x's, and then your maximums and your minimums are your y's. Alright, next section wants us to do the minimum and maximum of g of x, or f of x, g of x, however you want to call it, of log base 10 of x. And it wants us to do it on the given intervals. So number 13 wants us to find base 10, okay, at 0.1 and 10. So again, we've got everything going in one direction, right? So everything's on the ends. So my minimum will be on my left side at 0.1. Okay, 0.1 is 1/10, so that is 10 to the negative first power. My maximum is at 10, and that is 10 to the first power. Okay. Number 14, at 1 and at 100. Okay, so my minimum at 1 is 10 to the 0 power. Okay. Okay, I just had a brain fart. I don't know what I was just doing. Hold on. Okay, sorry, I had to get my head cleared out. I don't know why I was putting the 10 in there. All you need is the exponents. So, at point 1, my y is negative 1. Okay? And at max, at 10, my y is just a whole 1. Positive 1. Okay, then for for 14, at 1, my base, or my y is, or my exponent, my y is 0. My minimum is 0. At 100, my maximum is 2. Okay, I hope I didn't just completely confuse the crap out of you. I was writing it as the exponents, and you didn't need to. You just have to write the y, which is the exponent, but you don't have to write the base with it. So, again, number 13, 0.1 gives me a minimum of negative 1. 10 gives me a maximum of 1. On 14, 1 gives me a minimum of 0, and 100 gives me a maximum of 2. Sorry about that again. Okay, we've got log base 2 of x equals y. It wants us to graph it, and then we need the line of asymptote, the intercepts, domain, and range. This is number 17. Okay? Alright, so let's start off with graphing this. So, if I take base 2 at 0, base 2 to the 0 power is 1. Okay? Make that a little bit bigger. Base 2 of, let's see, 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. That gets us good enough for now. 2 to the negative first power is 1/2. 2 to the negative second power is 1/4. 2 to the negative third power is 1/8. Okay. Draw our lines in here. Okay. So there's our graph. Now, our line of asymptote. Our line of asymptote right here, where we're approaching, but we never quite reach it, right? So, my line of asymptote is x equals 0. My y and my x-intercept is right here. This is 1, or we can write it as 1, 0. Y-intercept, because we never reach 0, we have no y-intercept, so that's the empty set. Domain. Domain is everything that reaches x. So it never reaches this green line here. It's everything out that way. So my domain is x is such that x, let's make a better x there. X is greater than or equal, or not equal to, excuse me. It's just greater than. Remember, it's not equal to. X is greater than 0. Okay. And then my range, that's everything. It keeps going on down. It keeps going on up as it goes out. So, y is such that y is equal to all real numbers. Okay? Pretty easy. Okay, last one we're going to do. It says find the inverse and graph both on the same coordinate plane. So we're going to do y equals log base 8 of x. Okay, so to start out, we're going to turn that into an exponential, or into an exponent. So x is equal to 8 to the y power. Now we're going to find the inverse, so we're going to flip x and y. y equals 8 to the x. Okay, let's graph the first one. So we have 8 to the x, or log 8 to the x. So when 8 is 0, we have 1, just 1. When 8 is, when x is 1, we have 8. 1, let's see, 1, 2, 3, 4, 5, 6, 7, 8. There we go. And then when we have -1, we have 1/8. Right about there. Okay, and then getting on down there. So, something like that. And then we have y equals 8 to the x power. And remember, we have this is a reflection across y equals x. And change to my green colors here. So when we have 0, 1, we have 1, 0, we have 0, 1 for our reflected point. When we have 1, 8, we have 8, 1. 8, 1, we have 1, 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then we have 1/8 and 1/64. Alright, and that's what our graphs look like. Okay, that's the inverse graph for that. Okay, the rest of it is up to you. Have a good night, and I will see you tomorrow.